Hi, we are from Group 7 to present the mini project under the course of EEM353 Mechanical Engineering Design. The team consists of two members, Leong Kong Yu and Kelvin Tan Yi Bun. The task for this project was to implement the knowledge acquired in the lecture, mainly the process of product development. The product aiming to help the Society of Disabled Persons, OKU. The product that the team proposed is a stair climbing wheelchair. From the phase of opportunity identification, the team noticed that most of the stair climbing wheelchairs are fully motorized. This reduces the versatility of a product because the products were fully dependent on a battery source to operate. The prototype proposed was aimed to increase the functionality and create a wheelchair with more adaptable and universal use. Wheelchair with transitional mode between the manual and motorized operated wheelchair are proposed. Now, we will enter the prototype development process. The development process includes the 3D modeling in the CAD software, simulation using software such as Linkage and MATLAB, and the prototype testing. The simulation were done before the fabrication of the prototype. Simulations are crucial in helping the team to verify and validate the intended function of the prototype under development as well as the manufacturability of the prototype. The simulations were done using the Linkage and MATLAB with the aid of Simulink. The 3D design of the prototype was first created in the CAD software called SolidWorks 2020. The components of the prototype and the standard parts such as the fasteners were determined. The prototype was designed with a modular assembly because it consists of different functions. It will be easier to upgrade and improve on certain functions of the modular assembly design. Linkage software were used to generate the 4-bar linkage mechanism that was utilized in the transitional unit that converted from manual operated wheelchair to the stair climbing wheelchair. From the simulation, the team ensured that the linkage performed perfectly and did not cause extra strains such as excessive compression or tension in a member of the linkage. Next, simulation was done on the DC motor using MATLAB. The DC motors were modeled in a Simulink environment by getting the parameters of the motor such as the armature resistance, the windage inductance, the flux constant, and the moment of inertia seen by the motor shaft. The armature current and angular speed in radians second were plotted. From the result, the inrush current seems to be extremely high, which is expected from the DC motor working principle, that is, the rotor at stationary does not create a back EMF that impedes the armature current. The induced voltage in the motor is the function of the speed. However, there are limitations in a physical system that limits the current drawn from the motor driver by the motor. Meanwhile, the team developed the programs in the Arduino IDE. Then, testing of components on the breadboard and the 3D printing of the prototype were done simultaneously. Once the testing on the breadboard succeeded, the team carried on with the fabrication of the prototype. Finally, the prototype was fabricated and tested again. We will look into three aspects that are seat angle adjustment, transitional unit, and the stair climbing unit. First, the seat angle, measured by the IMU sensors, was printed to the serial port of the device to be monitored on screen. The angle of the seat is maintained at a range of -3 degrees to 3 degrees. The angle adjustment was done by a stepper motor mounted by the seat. Next, the transitional unit that converts the wheelchair from manual operated mode to the stair climbing mode was tested. Lastly, the track belt movement was tested. Finally, the routine of the prototype was tested. conclude, the concept of the stair climbing wheelchair proposed by the team was presented effectively through the demonstration of the prototype. That is all from Group 7. Thank you.